What if you have an equation that goes like this? Square root of x is equal to 3. And you want to solve this equation, obviously. You want to solve it for the variable x. Okay? As is true anytime you're trying to solve an equation, what you're trying to do is trying to get x by itself. So just as a refresher, if you have 3x plus 2 is equal to 4, what you need to do to get x by itself and solve for x is to get rid of this 2, which we do by subtracting 2 from both sides, and then after that's done, we divide both sides by 3. And when we do that, we will have x by itself, etc. Notice what we're doing here is in order to get x by itself, we're doing the opposite of the operation here on the board. So because this is a plus 2, in order to move it over, we just subtract 2. That's the opposite of addition is subtraction. Okay? To get rid of the 3 here, which is multiplied by the x, we do the opposite of multiplication, which is division. Okay? So solving equations is almost entirely about knowing what the opposite thing is. The opposite of addition is subtraction. The opposite of multiplication is division, and so on and so forth. The critical thing for equations of the type here with radicals is the opposite of a square is a square root. And the opposite of a square root is a square. So once we know that, we have everything we need to know to tackle an equation like this. So let's do that. The opposite of a square root is a square. So in order to get rid of the square root, what I need to do is take the square root of x and square the whole thing, the entire radical and everything. I square that. But of course, in order to make it legal, I have to do it to both sides of the equation, so I have to square that. What you will find when you do that is this square kind of cancels with this square root. Okay? So what you're left with is just x by itself. And that's equal to 3 squared, which you know by now is just equal to 9. So remember, the opposite of a square root is a square. If you want to get rid of a square root, all you have to do is square the whole thing, like that. And if you can just remember that, then you'll be in good shape. Okay, let's move on and we'll do some problems of various complexity. Okay, what if you have the square root of x plus 3 and that's equal to 2? Well, the first thing I should look at is I should say, okay, here's a square root and I need to somehow solve for x. So the first thing I need to do is get rid of the square root. So how do I do that? Well, I square both sides. Because a square gets rid of a square root, and I've got to square both sides in order to make it legal, because I can do anything I want to this equation as long as I do it to both sides. Okay? On the left-hand side, I'm just going to be left with x plus 3, because this square, if you want to make it kind of easy to remember, you can think of this square kind of cancels with the square root like that, so they just both disappear. Okay? And that's going to be equal to 2 squared, which is 4. And then in order to get x by itself, I just subtract 3 from both sides. And so then I've got 4 minus 3, so x is just equal to 1. Okay? And that's the answer to that guy. So you can see in all these equations, really it just comes down to knowing that in order to get rid of a square root, you need to square the quantity. And in order to get rid of a square, what you can do is take the square root. Okay? So just to kind of solidify things here, if you have square root of 6x, let's make that square root of 6 plus 2x equals 4. Again, to get rid of that radical, I just square both sides. So I've got to square both sides. The square goes with the square root. They cancel out. They kind of annihilate each other. It's like adding and subtracting. They kind of balance each other out. So I'm left with, on the left, 6 plus 2x equals 4 squared, which is 16. In order to continue solving here, I need to get rid of the 6, so I'm going to subtract 6 from both sides. I'm going to be left with 2x is equal to 16 minus 6 just gives me 10. And then to get x by itself, I divide both sides by 2. Again, doing the opposite here, dividing by 2, which gives me 5, because 10 divided by 2 gives me 5. Go ahead and work another problem over here. If I have something like square root of x plus 3 plus 5 equals 12, okay, well, I just have to look at this. I don't want to start squaring anything right away, because if I try to square this whole quantity, I'm going to have to do FOIL, because this will be the first term, and this will be the inside and outside and last, and I'll have a big 2 sets of parentheses I'll have to square. That'll be a nightmare. So what I want to do is I want to get rid of this 5 first. So I'm going to subtract 5 from both sides. On the left, I'm going to be left with this, x plus 3 all under the radical, equals 12 minus 5, moving the 5 over, gives me 7. Okay? And then here, I can just do x plus 3. I can square both sides. Okay? Again, the whole reason I did that was because the square cancels with the square root, and it just disappears. I'm left with x plus 3 equals 7 squared. 7 times 7, that's 49. And then, in order to solve for x, I just subtract 3, moving him over, and that gives me 46. So it's very methodical. The only difference between this problem and the previous problems is that I had this plus 5 here, and I just needed to move that over first. And once I did that, well, then the problem here looks very similar to the previous problems. So you see, we're kind of building things up slowly. We're taking things one step at a time, so there's no surprises, so that everybody gets it, and so that we build on things incrementally. Let's look at one that's a little bit different. What if I had the square root of 3x plus 3 equals 3 times the square root of x minus 1. Well, you might look at this and say, I have no idea where to start, okay? But if you just, this is why we're doing these problems, so that you can see how to start, okay? Obviously, you can't really subtract or add anything, because all this stuff is tied under the radical, and this stuff is tied under the radical here, so you really can't add or subtract anything. You could start dividing by 3, but that's not going to really help you, because you've got an x on both sides, and it's difficult to know what to do. But if you just work with me here, what we can do is we can, again, just like we've been doing all night here, we can square both sides. We can square both sides. That's no problem. On this side, the square is going to cancel with the square root, just like we've been doing all along, so I'm left with 3x plus 3. On the right-hand side, what I'm going to have here is this square. When you think about it, when you have terms inside of a parentheses and they're both raised to a power, what you really are doing here is you're distributing kind of this power into both terms. Okay, so what you're doing is you're raising each kind of term separately to the same power. So what I'm going to have here is I'm going to have 3 squared times, and I'm going to write it out in all its glory just so you can kind of see what I'm doing. At the biggest level, this is just equal to this squared, 3 times 3 squared, and also times this squared. So just continuing from the left, 3 times 3 is 9. In this term, the square cancels with the square root, so when I write a parentheses, I'm just left with x minus 1 here. So now I'm making progress. This is looking a lot simpler. So I can continue 3x plus 3 equals, I distribute this 9 in like this. So I've got 9x minus 9. 9 times x gives me 9x. 9 times negative 1 gives me negative 9. Okay? And then what I'm going to do, okay, is I'm going to move this 9x over here. So I'm going to subtract 9x from both sides of the equation. On the left, I'm going to have negative 6x, because 3x minus 9x over here is going to give me negative 6x. At the same time, I'm going to move this 3 over here by subtracting 3. So negative 9 minus 3 gives me negative 12. Now, if this looks confusing, I kind of did two things at once. I moved the 9x over here by subtracting, gives me negative 6. 3x minus 9x, negative 6. 3 gets subtracted to move over here. Negative 9 minus 3 is negative 12. So then x is just going to equal negative 12 over negative 6, which is positive 2, because negative divided by negative gives me a positive. Not too bad, right? Okay, so the problems are getting a little bit more difficult. But again, you can see once you know how to start, they're not really all that difficult. What if we have one like square root x plus 1 equals x minus 1? Okay? Really, I've got the same fundamental problem. I can't do anything with this x tied up under the radical. So I know that whatever I need to do, I need to get rid of this radical, and the only way to do that is to square both sides. So we're going to go square root of x plus 1, raise it to the second power, equals. And I need to square the right-hand side. Now don't fall into the trap of trying to square this term separately and this term separately. Okay? Remember, when this is kind of bound together by this minus sign. You can't just work on these individually. In order for this to make mathematical sense, you've got to tie them together and square the quantity. Okay? And that's just the way you have to do that. On the left, the square cancels with the square root, so I'm left with x plus 1 equals. On the right-hand side, I'm going to write this out, x minus 1 times x minus 1. And that's what it is, exactly, this quantity times itself. So let's start simplifying that. I'm going to use FOIL, remember that. First, outside, inside, last. Okay? X times x gives me x squared. The outside terms, x times negative 1 is negative x. The inside terms, negative 1 times x, again, is negative x. And the last terms, positive 1 times, negative 1 times negative 1 gives me a positive 1. So I've done FOIL to expand this. So over here, I'm just going to have my x squared. These two terms combine to give me negative 2x. Negative x minus x gives me negative 2x plus 1. Okay? So what I'm going to do next is I'm going to start moving this stuff over here to try to get all the x's and all the constants on one side of the equation. Okay? So I'm going to move this x over here, and I'm going to move this 1 over here. So what I'm going to have in the end is 0 equals x squared. Negative 2x minus x gives me negative 3x. Okay? And then 1 minus 1 gives me 0. Okay? So if you're confused by this, just think about it this way. If I were to subtract this 1 over, well, this 1 cancels with this one because 1 minus 1 is 0, so these 1's disappear. Finally, if I subtract x from this side, I'm going to be left with 0 on this side. And then when I move it over here, it's going to be negative 2x minus x, which gives me negative 3x. So my equation is x squared minus 3x equals 0. I can solve that by factoring out an x. Convince yourself that this is true. X is common to both terms here, so I can pull it out, put in my parentheses, and figure out what needs to go in the inside. In order for the first term to be equal to x squared, I've got to put an x here, because x times x gives me x squared. That checks out. And on the last term, all I need is a 3, because x times negative 3 gives me a negative 3x. So this is equal to this. And of course, it's equal to 0. Okay? When I do that, let's continue over here. When I do that, if you remember back from solving equations from the first video in the course here, x is equal to 0, so you can say that right off the bat. And x minus 3, quantity, is equal to 0. And of course, the second equation just implies x equals 3. Okay? So these are two possible solutions, x equals 0, x equals 3. Okay? Mathematically, we've found two possible solutions. The reason that we found the two solutions is because when you factor it out, this quantity, this whole thing has to equal 0. The only way that can happen is if this one's 0, if x is equal to 0, well, 0 times anything is going to give me 0, so that could be a solution. Or if this quantity is 0, this quantity being 0 times this would also give me 0, so that's why I did this, and we solved for x. But in order to go forward, we need to check and see if either one of these are actually a solution. Okay? So if we put 0 in here, if we just think about that, 0 plus 1 is just 1. Okay? So that would be a square root of 1, which would just be 1 on the left-hand side of the equation if we put 0 in here. If we were to put 0 on the right-hand side, we would get a negative 1. 0 minus 1 is negative 1. So if we put 0 on the left, we get positive 1. If we put 0 on the right, we get negative 1. That obviously is not true. So this solution, even though it was a possibility, we discard it because it's not true. Now we check our second solution, see if it's true. 3 plus 1 is 4. Square root of 4 is 2. So remember that, 2. 3 minus 1 is 2. So this solution checks out, and that's the answer. So anytime you get multiple solutions to an equation, plug them back in, make sure that they're both valid, and that's how you go from there. It's always a good idea to do that, just to make sure that you kind of sanity check your solution there. Because we saw in this case that we found multiple solutions, but in fact they both weren't actually valid. We'll do a couple of problems involving cube roots, and we'll call it quits for this section. What if you have the cube root of x minus 1 equals 4? How do you solve that? Well, it's really very similar to what we were just talking about a minute ago. The opposite of a square root is a square. The opposite of a cube root is a cubed. So in order to solve this, all you need to do, you've got x minus 1. This is a cube root. All you need to do is raise both sides to the third power. Remember, whatever you do, you have to do it to both sides. The cube is going to go out with the cube root. You're going to be left with x minus 1 equals 4 cubed, okay, which is just going to equal 64. If you put that in your calculator, this is just equal to 4 times 4 times 4. 4 times 4 is 16 times 4, and you'll see that that gives you 64. Okay? So x minus 1 is 64, so then x is equal to 65. Because I just moved the 1 over here, add 1, that's my answer. The only thing I'm doing this, it's really very similar to the other problem, is just to prove to you and to kind of illustrate to you that the opposite of a square root is a square, the opposite of a cube root is a cube, and on and on. If you have a fourth root, you know, a square root symbol with a 4 up there, and you need to cancel it, you just raise everything to the 4th power, and you're good to go. So let's say you had 1/2 x minus 3. This is all raised to the cube, or all inside of a cube root, and that's equal to 2. Again, I want to solve for x. I've got to get rid of this cube root, and the way I do that is by taking everything here, raising it to the 3rd power, raising the right-hand side to the 3rd power. Okay? The cube cancels with the cube root. I'm left with 1/2 x minus 3 equals 2 to the 3rd power is 8. 2 times 2 is 4. 4 times 2 is 8. So that's why you get that. So then you have 1/2 x. I'm going to move the 3 over by adding 3 to both sides. 8 plus 3 is 11. Okay? And then in order to get x by itself, I'm just going to multiply both sides by 2. And I'll show you why that works right here. If I multiply this side by 2, I have to multiply this side by 2. The equation's valid, right? On the left-hand side, if I do this, I'm going to have 2 over 2, which goes away. So it's going to drop out because 2 over 2 is just 1. So I'm going to have x on the left. That's what I'm trying to do. I'm trying to get x by itself. Equals 2 times 11 is 22.